Okay. Good afternoon. Yeah. It is a pleasure to be here and share some of the things what we have been doing. The focus is on offload. As we heard in the introductory comments by Jason, there is a lot of work taking place, a lot of different devices are coming up. The question is like how do you really take advantage of those in a context of a common middleware or software. So, the title here is accelerating HPC and AI applications by offloading computation and communication to SmartNICs, and I am DK Panda from the Ohio State University. Now, if you take a look at a very modern clusters at a very high level, we have all these different components, multi-core processor, many-core processor, accelerators, of course, different interconnects or the SmartNICs, and especially this is where the DPUs are coming, and of course, the storage. And that is the kind of the commodity environment we see in a lot of systems, which are being deployed both on the on-premise as well as on the cloud. So, then the question is if you are trying to run or the design some kind of a middleware, I will focus both on the HPC side as well as on the AI, and especially focusing on the communication and computation. So, how do you really design those kind of a middleware for both HPC and AI systems while taking advantage of the heterogeneous resources. So, when I say heterogeneous, it is like a CPU, GPU, DPU, IPU or in general XPU, that is what we will be focusing on. So, this will be kind of an outline. I will start with one of the projects which I have been leading for last 25 years. It is called a MAPIC MPI library projects. I do not know how many of you know that. If not, I will introduce that in my next slide. And then over the years, we have done a lot of different kinds of offloading strategies. So, I will go into some of these things, the strategies as well as benefits. Like I will start with some MPI level, non-blocking collectives, blocking, those will be focusing on communication, but then also I will be focusing on some point-to-point and also collective, where we want to involve like rather offload both computation as well as communication. And then I will focus on some one-sided operation in the context of both MPI and Open SMEM. The SMEM standard is also gaining momentum, that is on the communication aspect, and then some smart compute offload, which focuses on the computational offload. And then finally, I will also try to see how you can even in the AI workload, how you can take the offload. So, that will be kind of the rough outline of the presentation. How many of you are familiar with the MAPIC MPI library project? Okay, many of you. We started this project almost the day one of InfiniBand. How many of you know InfiniBand? I am sure all of you know. Okay. October 2000, it was introduced almost 25 years back. Prior to InfiniBand, the older interconnects, I do not know many of you remember, used to be Mininet, Quadrix. Okay. Some of you are there, old timers. So, we were working on the communication stack at that time, and when InfiniBand came, in my group, we were the very first group in the world to jump into directly saying, okay, how you can take advantage of InfiniBand, RDMA and all those mechanisms to really into a software stack. And we did that with the context of MPI, which is a message passing interface library, very commonly used for HPC. And we had actually our first demo at Supercomputing 2002, okay, in Baltimore. And if I tell this, like at that time, even though we were showing a demo, running an InfiniBand cluster with only 8 nodes were struggling. Okay. Now, you see in the market it is 8,000, 16,000, you just add 1,000 and it is still stable. And I am very proud of my team. We are running this from a academia, but running for 24 plus years. Okay. So, we generated that open source stack. Of course, it was initially for InfiniBand, but now we support all interconnect. Any HPC interconnect like Omnipath, Ethernet, iWarp, Rocky, AWS EPA, OPX, Broadcom Rocky, Intel Ethernet, Rockport, Slingshot, and we are also keeping a track of all the Ultra Ethernet Consortium, Scale-up Ethernet, all those things to account. Of course, there are a lot of different versions. So, currently if you see on the right hand side, this stack is now being used by more than 3,400 organizations in 93 countries. So, organization means one HPC center. If you think of like Texas Advanced Computing Center is like one organization. But on that again you will be seeing like 10,000 people are using. So, like this if you see all over the world, like people are using it almost like several thousand, hundreds of thousands of people are using this stack, and we are hitting from our website very close to 2 million downloads just from our website. Okay. Of course, it is a part of Red Hat, SUSE, SPAC, Open HPC, we don't keep track of those. But it's not just the number, but it's also enabling a lot of top 500 clusters over the years. So we started from the group, but now the stack can actually run on 10 million cores and all. And in addition to the MPI library, the left-hand side, you will see we have something called a OSU MPI micro benchmark. That also very extensively get used to evaluate like how you really measure MPI level performance. And that also has become like an industry standard in the sense when you look at a lot of procurement, many times you will see a line saying, okay, please report the MPI numbers using the OSU micro benchmark. So we have been able to standardize that also. So this is a big architecture, the software architecture of our MBAPS library. You can see at the bottom left is most of the networking technologies. The right-hand side is more of the CPU, GPU, DPU. And then the middle one is actually our interesting thing. We start with research. We come up with better solutions for, let's say, for point-to-point, collective, startup, energy awareness, etc. Not only we publish, but in 3 to 6 months, we actually take these solutions and really push it into our open source stack. Okay, so we have in our group a part of like a really managed by software engineers full time, but everybody works together. So that not only we publish the results, but we also push it to the production quality code so that people can just use it. So originally we started like a top 2 rows. If you see, we started with MPI. Over the years, we have also expanded to PGAS, UPC, OpenSMEM, etc. And of course, the top, that was our HPC was the main thing, but we have also expanded because the MPI library actually provides scale up and scale out. Now, any stack you say, it's not only HPC, let's say AI stack, you also need the scale up and scale out. So I'll not focus in this talk, especially a little bit later, but we have actually provided, we have a separate project, deep/machine learning, so you can actually run PyTorch, distributed PyTorch over MPI. You don't need any like a nickel library, RICL library, or any of the XACR library, and we perform equal or better performance. Because all these collectives have been there with the MPI world for last 30 years. I don't want to offend anybody, but the AI world is rediscovering those collectives. All right, it has been with the MPI for last 30 years. So we know how to optimize these for all CPUs, GPUs, and all. So that's how we do. And we also like a big data, data science. You can also run like stacks like Spark, Dask, everything we have linked also to the MPI. So we are trying to push from our group saying MPI is a vendor neutral stack and which can actually provide you both scale up and scale out for any of your workload. Okay? So that is the kind of the bigger thing in our group we are working on. But today I'll be mostly focusing on only the like the DPU aspect. So let's start with this offloading strategy and benefits. So if some of you might be familiar with this like a Bluefield 3 DPU. So here if you see like on the top level, so that is like a host server and bottom is the Bluefield. In addition to the RDMA logic, we have a programmable set of ARM cores. Now I call it this like a executive secretary approach, okay, or executive or assistant approach. How many of you are here managers who have assistants and secretaries? I'm sure many of you have, all right? So let's say you want to hire an assistant with a PhD degree capability, okay? What can you offload? Everything, right? You tell this guy, depending on your organization, you say, if you are a researcher, you say, go write a proposal, get the funding, do the work, write the papers, just put my name, right? That secretary will do everything, okay? But on the other hand, if you have a secretary which has only a high school degree, what can you offload? Limited things, saying, okay, extend help with me in emails or setting up this Zoom meeting or write this paragraph, cut and paste. So this is where actually the world is now. So many vendors are coming up with different kinds of devices, you say XPU, but the offload mechanisms, you need to take a decision, how best to overlap, how best to get the performance, and the most important is of course the cost. Okay, I'll come to that later on. So that is the kind of the broad paradigm. We have taken this executive assistant paradigm to see how you can actually offload different parts of the middleware. That's what I'll try to show so that it will give you an example. We have done published with Bluefield 2 and Bluefield 3, but it is generic. Those concepts can be used for any other devices. Okay. So let me start with a very simple thing. This is what we started like almost 5 years back, blocking collectives. Okay. So in the MPI library, those of you are familiar, like a lot of collectives, let's say I want to do all to all. So that means the processor start the, let's say, all to all, but unless the all to all gets finished, they are not progressing, they are just checking. Okay, it's just like executive, initiated some operation to outside world and then raising the leg and sitting in the chair until the things finishes. So that means if you see this communication, there is no overlap of computation and communication. So it is just like you hire a secretary, pay the money, but you are not changing anything, so you don't see any benefit except you pay the money. All right. So there is no overlap of computation and communication, so this is inefficient. Okay. So this is where the MPI standard many years back introduced these concepts of non-blocking collectives. So that means if let's say the same all to all I am trying to do, but instead of blocking all to all I can do non-blocking all to all. So that means I initiate the operation, but while the operations are going on, I can actually focus on some computation which is independent of that communication. That means let's say there is some results from the previous thing, I can actually work on that. And that's what most of the managers do. I mean, your assistant and secretary, you give something, but you are not sitting idle. Okay? You are waiting, you are working on something else, and if I can do that design properly, this is where you will see real benefits of computation and communication, and your application execution time will reduce and you will get the higher throughput. And this has been there in the MPI standard for some time, but then the question was in the traditional MPI implementations, the question was who will do this kind of like a checking of the offload. Okay? So this is a very prime candidate for the DPU. Okay? So if you have a DPU, then very quickly you can offload that part, and that's what we started. So if we do this, then you will get overlap of computation with communication, it will reduce the overall application execution time. But then the major challenges are how do you communicate? Just like, let's say you are a manager, you had a secretary, you have to change your mind, saying how should we communicate with this secretary? What language do I talk? Okay? And I should understand the capability of the secretary, accordingly we can work together, whether it is a computation or communication. And especially if you have like a, let's say the Bluefield 3, we have a bunch of server cores, but also a set of DPU cores. So think of like the group secretaries, there is a bunch of secretaries for a bunch of managers. So you need to come up with those mechanisms, so you need to redesign. So this is our first solution we had. We have actually a library called MAPIS to DPU. This was actually done jointly with a startup called Xscale Solutions. So it's a commercial product. It's a derivative of the MAPIS 2. So we offloaded this all to all Bcast. Now if you take a look, these are done with all micro benchmarks. And of course, in the non-blocking strategy, you need to see communication only latency is not important. Now it is a computation plus communication matters. Okay? And that's what we were able to show. Like let's say 32 node, 32 ppn, like 1,000 core experiments, you can get 46% benefit. But then the question is the application also has to be modified. This is very important. Just like as I said, if you are an executive, you didn't have an assistant, your manager says, yeah, now you can hire an assistant, but then you need to rethink your workflow. Otherwise, you will not see any benefit. So that's what the application has to be modified. So we modified here like a P3D FFT, which is very communication intensive, and we are able to get, like you see, on a 1,000 core experiment, 24% speed up I can give. It's the same hardware. It is just like changing the software, I can boost the performance. Same thing we did with there is an MPI, there is a non-blocking Bcast, and I can see like a 65% benefits. And then one of the application which a lot of HPC people use called high performance LinPack, you would have seen like those top 500 numbers, we are able to boost 10%, 15%, 18% of that HPL, and that makes a big benefits in your ranking without adding any resources. Just by changing the middleware, we are able to boost the overall ranking of the system. So that is like a very simple things we started. So then gradually we went into more extensive things. So a lot of HPC applications also use stencil communication. Okay? So that means it is a 5-way stencil, 7-way stencil. So that means I am doing some near neighbor communication, and there again we try to do similar kind of like offload to the DPUs, and here you can see like a 18% benefits we see. So then we went into a little bit more complex things, here into like a PETC. PETC is a software library which is very widely used in a lot of HPC applications, and there again we are able to solve like those 3D Laplacian 27-point algorithms, and you can see like an 18%, 20%, those green lines are better. And then we went into one-sided operation. MPI has like a RMA operation, and now recently the SMEM like NB SMEM and all are getting very popular. So, the similar results we also got it here. You can see both on the left hand side, right hand side, we can give you a significant benefits. And then this was the most complex thing we have done, even the compute can I offload. Okay? But here you have to be very careful, because these DPU cores are not very powerful. If I just blindly offload, it will not help. Okay? So, think of like an executive and secretary. Let us say I am trying to write a document, I can tell my secretary, oh, go do the reference section you do, but I will write my executive summary. You need to intelligently decide what your secretary can do, what you can do. The same thing we used here. So, this is a paper we published just last December, and of course, it depends on the ratio of the CPU and DPU speed. So, we perform like two kinds of things, like if you see Intel Broadwell with BF3, Intel Sapphire Rapid with BF3. So, the Intel Broadwell is a older technologies, and the DPU is faster, so we can get 24% improvement, whereas the Intel Sapphire Rapid is much more powerful. So, then we get still like a 10 to 15% improvement. So, you need to think again in a very intelligent manner what I can offload. And then in the DL training, so this is a CPU based DL training. If you take a workflow, this is how you will see, like there are some data augmentation steps, then training, model validation. So, all these like a 6 phases are there. So, we actually profiled each one of these and then trying to see which is the best way to offload, and that is what we came up with. So, this was a Hot Interconnect 2021 paper saying we can do the training process on CPU, data augmentation on DPU, testing process on DPU, and that also led to with this startup company. We have a Xscale AI DPU package. It can actually have the DPU taking the advantage of the offload. And here if you take a look at like a ResNet 20 V1 model with CFAR 10 data sets, 20% benefits we are able to give. So, in the same training is running, but now the DPU is helping the CPUs to perform the operation. So, those are the kind of the published results we have. So, more things are going on. So, with this I would like to conclude saying the DPU technology again provides a novel ways to offload the computation and communication from host CPU to DPU core. I demonstrated multiple ways to take advantage of it, and how you can from the same hardware you can actually try to deliver the better performance. But the open question here, this is what I indicated by motivational example, can the performance benefits match with the additional cost of DPUs? Okay? It's just like I told you like hiring a PhD level secretary, but if you cannot offload 100%, then it is not beneficial. And how much cost you are providing to the secretary and how much benefits you are seeing. So, that is how like whenever you try to propose a DPU technology, you need to see how much you are able to sell it. If I only get 20% benefit, but if the vendor is charging 5x, nobody goes for it. Okay? So, that is the kind of the cost performance trade-off we need to keep into account. And I just indicated that a lot of vendors are working on these. We will be very happy to work with all of you depending on the software, what you want to, and then the application. So, with this I will be happy to conclude here and take few questions. This is my email address, and if you have any questions, I will be here tomorrow also, we can talk. Thank you. Any questions?
All right, I guess not. Thank you.
Thank you.